Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe the channel. In this video I will discuss the key points of quick revision of inorganic chemistry. Uh, let's start. The periodic table, chemical periodicity. Chemical periodicity, you know that periodicity is a regular pattern of repeating pattern in physical, and periodicity mean repeating pattern in physical and chemical properties. Property across the periods in the periodic table. So candidates should be able to describe qualitative and indicate the periodicity in the variations in atomic radius, ionic radius. Atomic radius, you know that atomic radius or size of atom is decreased. Atomic radius or size of atom decreased across the period due to the reasons are increased nuclear charge, same shielding effect, greater force of attraction exerted by the nucleus due to increasing number of electron. So these are the electrons, and this is the graph of atomic radius. Sodium, and this is still argon and chlorine. So this is nanometer and variation of atomic radius. So this is the graph, look like this is argon of atomic radius. So these are the reason that why atomic radius is going to decrease across the period. So next is the ionic radius. There are two types of ions, positive and cations and anions. Positive cations and anions. Cationic radius is much smaller than the parent atom. due to losing of electron with decreasing the shells, number of shells. So in this way the atom becomes smaller after losing of electrons. Anionic radius is much smaller. Sorry, anionic radius, this is about cationic radius, and anionic radius is much larger than the radius of parent atom. As non-metals gain electrons, so this is the due to the reason repulsion between the electrons, repulsion between the electrons in the outer shell increases due to increases, so shell expands and ionic radius increases. So in the hold of nucleus on the valence shell, electrons are decreased. So these are the reason decreased. So these are the reason why ionic, cationic and ionic radius are increased or decreased. So melting point of a solid is the temperature at which it is in the equilibrium with the liquid phase, and melting point is decreased. Melting point is decreased across the period, like sodium till silica. Sodium till silicon is increased, then decreased afterwards, because this is sodium till, if we explain sodium till argon, so this is sodium, then this is silicon, and then phosphorus, then sulfur, then chlorine and argon. So this is the trend of the melting point. And you know that the sodium has one valence shell electron. Melting point depends on the number of valence shell electron which are localized in the metallic lattice. So across the period till silicon, number of electrons are going to increase, so that's why melting point is increased. So phosphorus is simple molecule and non-metal. Sulfur is also simple molecule. Phosphorus is P4, sulfur is S8. So generally melting point is decreased from phosphorus to argon, but phosphorus has less electron than sulfur, S8. The molecular formula of sulfur has S8 and P4, so that's why it has high melting point than phosphorus, and generally from phosphorus to argon melting point is decreased. And silicon is giant macromolecule, so that's why it has high melting point. Sodium, magnesium, aluminium has high melting point, and silicon as the in the period 3 silicon is highest as it is giant macromolecule. These are the metallic lattice, so that's why they have their melting point is increased as the electrostatic force of attraction increased due to increasing the number of valence shell electron. Similarly, electrical conductivity, this is the trend of electrical conductivity, is sodium, magnesium, aluminium, and this is silicon, then phosphorus, sulfur, and chlorine and argon. Melting point electrical conductivity is increased from sodium till aluminium because these are metals, and metals conduct electricity in molten and solid state due to free moving electrons, free delocalized electron, valence shell electron. But silicon is a non-metal, phosphorus is a non-metal, sulfur is a non-metal, they don't have free moving electrons, so that's why this is P4, this is S8, and this is argon, so that's why they cannot conduct electricity. And this drop from aluminum to silicon because it has macromolecular structure and there are no free electrons. Conductivities of the remaining elements are very low because they are all simple molecule substance, so that's why electrical conductivity is going to. Periodicity of chemical properties of the elements in the period 3 learning outcomes. Candidates should be able to describe and write equation for the reaction of the elements with oxygen to give sodium oxide, magnesium oxide, aluminum oxide, phosphorus 5 oxide, and sulfur dioxide. So